Hi students, problem number 3 in Doppler effect. A train standing at the outer signal of a railway station blows a whistle of frequency 400 Hz. So 400 Hz is the actual frequency emitted from the whistle. In still air means what? Air is not moving. So velocity of the medium is to be taken as 0. What is the frequency of the whistle for a platform observer? Platform observer is assumed to be at rest, stationary listener. So VO is equal to 0. So when the train, in these two cases, first one is train approaches the platform with a speed of 10 meter per second. Train is approaching means V is velocity of the train, velocity of the source is positive. Then it recedes away from the platform with a speed of 10 meter per second. So in the second case, the velocity of the source is minus 10 meter per second. In both the cases, velocity of the sound in air has to be taken as 340 meters per second. So what are all the given quantities we will write first? Velocity of the observer is 0. Velocity of the medium is also 0. And the velocity of sound in air is 340 meters per second. And the actual frequency in both the cases is what? 400 Hertz. Now case 1. In the first case, velocity of the source is equal to 10 meters per second. Okay. So in this case, you can see that if this is the source, it is approaching the stationary observer. So observer is at rest. So when the source is moving along the positive x-axis, then the apparent frequency f dash is equal to actual frequency into V plus Vm minus Vo divided by V plus Vm minus Vs. This is the general formula. So in this Vm is equal to 0, Vo is also equal to 0. Therefore f dash is equal to f into V divided by V minus Vs. So that this is equal to 400. F is equal to 400 multiplied by velocity of sound V is equal to what? 340 divided by 340 minus 10. So that this is equal to 400 into 340 divided by 340 minus 10 is 330. So this is equal to 400 multiplied by 34 divided by 33. So now we can use the calculator. Okay, 400 into 34 divided by 33. What is the product of 400 into 34? So this is equal to 13,600. 13,600 divided by 33. So this is now divided by 33. So this is 412, nearly equal to 412 Hertz. So f dash is now equal to 412 Hertz. Now case 2. In the second case, the source S is receding. It is receding away from the stationary observer. So in this case now, the velocity of the source Vs is equal to minus 10 meters per second. Therefore f double dash, this symbol f double dash, here f dash I have used, therefore f double dash I am using. So this is f multiplied by V minus Vo divided by V minus of minus is Vs. Okay. So that this is equal to 400 into velocity of sound is 340 divided by 340 plus 10. So this is equal to 400 into 340 divided by 350. So that this is equal to 400 into 34 divided by 35. So 400 into 34 divided by, so 13,600 divided by, this time denominator is 35. So f dash is now equal to 388, nearly 388.6 hertz. So we have already studied Doppler effect. When the source is approaching, when the source is approaching the observer, there is an increase in the frequency. So 412 is greater than 400. And when the source is receding away from the stationary observer, there is a decrease in the frequency. So 388.6 is less than 400. I hope you must have understood well. Fine.